Okay, here we go. This is Comp 361, Lab 3. Question A. What does it mean for an arc to be consistent? An arc XRXY is consistent as long as for X in domain Y, in domain X, there exists Y in domain Y where R of XY is satisfied. This is the direct textbook definition from the slides, and this basically means that for an arc, there needs to be in the domains of the variables or the what are they called? Are they this part? Yeah, in the variables. Um, there needs to be a for any x value, there needs to be a y value where that rule is satisfied. And then what does it mean when a network is consistent? It's when all of the arcs in that network follow that previous rule. What are the possible outcomes of arc consistency algorithm? So one domain is empty, and that is no solution. And then 2 is all domains have singular values. This means all the domains come to like one singular value each. So like say, I don't know, if you have a domain of 3 variables and they come to 1, 2, and 3, then that's it. That's the solution, and it's the only solution that can be. And then it's unclear what the solution is if there's multiple variables. So basically, you need to do more work and figure it out. So this here, the constraint satisfaction problem. So to start off, if you check the consistency of each arc itself is consistent, because for if A is T, then B can be F, or if A is F, then B can be T. And so it doesn't reduce the number of variables in the domain of each variable. It doesn't reduce that. But to finally solve the problem, you find out that the entire network as a whole has no solution, because as soon as you introduce the A does not equal C, B does not equal C to that, now you have a situation where C can't exist. So, and that's also why when they have multiple values, a solution isn't guaranteed, because say even after arc consistency is ran on this, you find that it still has multiple values and it still has no solution. So there's no solution guaranteed. And then we go to the AI space here. And this is just the basic setup. So the way I've set up the flags is, or not the flags, the constraints is if they're the same, it's not true. And that's how all of them are set up. And we can just go to solve and auto arc consistency. So we check the arc consistency first, and we find that all the arcs are consistent. But then if we do auto solve, we eventually find that there is no solution, which is my exact prediction from D. Just wait for it to go through. And there we are. Perfect.